We did 13-5 probability models. The learning objective is to construct and use probability models. In the introduction, it shows the number of students who passed their driving tests as well as whether they took a driver's education class to prepare. It shows two different frequency categories in this. Two-way frequency table displays the frequencies of data in two different categories. Problem 1. The table shows data about student involvement in extracurricular activities at a local high school. What is the probability that a randomly chosen student is a female who is not involved in an extracurricular activity? In order to find the probability, you need to calculate the relative frequency. To solve the problem, think what is the connection between relative frequency and probability. You are able to use relative frequency to find the approximate probability. Go over what is known about the graph. There are two different categories, both male and female. This problem seems more complicated than it already is. All you need to do is compare the number that you are assigned against the total, which is already provided for you. There are 120 females that are not involved in activities. Divide that by the total and you get 516, which is 23.3%.
Alright, so now we are going on to problem 2, but first some vocabulary beforehand. So if you see this word highlighted here, it says conditional probability. Now all that is really saying is just what's the probability of, say, event B, given that event A has already happened, it's already occurred. So if you go on to problem 2 here, finding probability, it's asking you, respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. What is the probability that a randomly selected person is over 60 years old, given that the person had no opinion on the bill? First, I should point out that it's probably totally inaccurate that there are lots of young people against raising the minimum wage, but anyway, about the graph here, it looks pretty complicated. There are a lot of different categories, but all we're really doing here is something that we've been doing since elementary school. You're filtering out unnecessary information. All we need here is this no opinion column. And in that, all we need is the category, or is this number 40, because those are all the people over 60 that had no opinion. Because it's over 100, it's really super easy. You just put it over 100, and that's your percentage. It's just 40% chance. Okay, now we're going on to problem 3. Now this one is about using relative frequencies. Let me read it to you. A company has 150 sales representatives. 2 months after a sales seminar, the company vice president made the table of relative frequencies based on sales results. What's the probability that someone who attended the seminar had an increase in sales? This is another one that looks pretty complicated. The values don't seem right, and that's because they've all been reduced by about a scale factor, you could say. They're all expressed sort of as a percentage here. So that means there are, a couple different ways of solving this. Now, the first way to solve it is to use what you know about the number of attendees, which is 150, and multiply everything by 150 to get the correct, the correct numbers in the graph. That would yield you the result of 72 over 120. That is the people who attended the seminar and did see an increase in sales. So 72 over 120 will give you 60%. Now there's another way to do this, and that is simply put the relative frequency values in the same problem, which would be 0.48 over 0.8, and that also gives you 60%. And the reason that works is because these are all expressed, as a percentage of 1, and therefore the proportion between them is going to be the same no matter, what the numbers are. So that is section 3-5. I hope that we can help you guys with that. Goodbye.